Hello and welcome to the second part of the VR tutorial series. Today we will be adding a full body IK to our VR character. If you haven't watched the first part, make sure to do so since this tutorial will be building on it. Assuming you don't already have an asset with animations, let's add the mannequins and animation starter pack. I'll leave a link to both asset packs in the description. When you try to add them, but you don't see your project, tick the checkbox Show All Projects. Select your project, choose the latest available engine version and select Add the project. In your project, open the previously created VR character blueprint. Select the mesh and choose the SKM Mani skeletal mesh. If you want to use a physical animation, scroll down to the physics settings of the mesh and change it from character mesh to custom and select collision enabled, query and physics. If you want the mesh to be able to collide with itself, change its object type to physics body. The next step is to create a new variable called height of type float. Compile the blueprint and set the default value to your height in centimeters. We will add a way to dynamically set the player's height in a future video. Next, we need to apply that height, so let's get to the functions panel on the left and create a new function called apply height. In that function, we want to get the mesh and call the function setWorldScale3D. Get the created height variable and divide it by 180. 180 is approximately the size of the UE5 mannequin. Then we input this value as a new scale for the mesh. To know if the player is standing, crouching or proning, we want to get the ratio between your actual height and the character's current height. To do this, we create a new function called getHeightRatio. Select the function and add an output of type float called heightRatio. Next, get the scaled half height from the capsule component, multiply it by 2 and divide it by our height variable. Also make sure to tick the pure checkmark so we don't need to connect any execution pins to the function when calling it. Next, we need to adjust the update mesh location and rotation function, because when we go from crouching to proning, we need to move the mesh backwards a little bit, because the head would be too far ahead of the camera when laying on the floor. Start by disconnecting all execution pins. Then add a sequence and connect the set world rotation node to the second output. Move the rotation part out of the way. Next, call the getHeightRatio function and check if its value is less than 0.6. You can play around with this value. I chose it because it worked best for me and seemed to be quite accurate for crouching. Next, add a branch to the first output of the sequence and input the less than comparison. Connect the previous setWorldLocation node to the false output. We need to make some adjustments to its location calculations as well. Disconnect all location inputs and recombine the pins of the capsule location. Get the camera's forward vector and normalize it to a 2D vector. Then multiply the value by 20. You can change the pin value type by right-clicking it and selecting to float double precision. We want the mesh to be some distance behind the camera because otherwise we would be able to see our own head. If you don't want to do it this way, you can also separate the mesh from the body and hide it from the owner. However, for this tutorial we will use the standard mannequin model from Unreal. Next, we want to subtract the calculated distance from our capsule location. Split the output pin and connect it as it was before. Now copy the whole block of nodes and connect the setWorldLocation node to the true output of the branch. From the getHeightRatio, get the node MapRangeClamp, set the inRange A to 0.3 and the inRange B to 0.6. The outRange A should stay 0.0 and the outRange B should be 1.0. Then invert that value by subtracting it from 1. Next, get the normalized 2D vector of the camera's forward vector and multiply it by that value and the float value of 30. These values are values which work for me so far. You might want to adjust them and experiment which values work best for you. At last, we subtract the new vector from the capsule's world location. This makes sure that the mesh moves back when transitioning from crouching to proning. Next, go back to the event graph and create a new custom event called initPhysicalAnimation. If you don't want to use physical animations, you can skip this step. Get the mesh and call the function setAllBodiesBelowSimulatePhysics. Tick the new Simulate checkbox, drag out the in-bone name and search for Make Literal Name. For performance reasons, we will only simulate physics on the arms of the player. However, you can also apply this below the pelvis to simulate the whole body. Just make sure to untick Include Self when doing so. In the Make Literal Name node, set the bone name clavicle R as an input and duplicate the nodes. Change the bone name to clavicle L in the second Make Literal Name node. Then add a delay of 0.2 seconds. This delay is necessary because when spawning characters that use physical animations, the engine tends to crash randomly when initializing the physical animation too early. Go to your components and add a physical animation component. Get the component and call setSkeletalMeshComponent and input your mesh. Then call Apply Physical Animation Settings below and connect the clavicle R name to it. For the physical animation data, drag out the pin and search for Make Physical Animation Data. Again, if you want to simulate from the pelvis, untick Include Self. Otherwise, duplicate the node and connect the clavicle L name to it. For the physical animation data, untick is local simulation, set the orientation strength to 10,000, the angular velocity strength to 1,000, the position strength to 10,000, and the velocity strength to 1,000. This is it for the physical animation part. All we have to do now is just to go to the begin play function and call our apply height and init physical animation functions. Let's move on to the animation blueprint. In the blueprint folder, create a new folder called Animation VPS. In there, create a new animation blueprint by right-clicking and navigating to Animation and selecting the Animation Blueprint. Select the SK Mannequin skeleton. I'll call the blueprint AVP_VR character. Inside the animation blueprint, go to the event graph and get the begin play event and cast the try get path owner to your VR character blueprint. Then promote the casted character to a variable and call it VR character reference. Next, we want to tell the animation blueprint where our camera and motion controllers are. From the update animation event, we want to check if our character reference is valid. Then add a sequence with 4 outputs. Create a new variable of type rotator and call it camera rotation. Get the camera from our character and get its world rotation and set it as the camera rotation value. In this tutorial, the position of the head will be set by animations and not by camera. Let me know in the comments if you want to see a tutorial where we use inverse kinematics and procedural animations. Next, create 2 new variables of type transform, one called RMC transform and the other LMC transform. These will be the transforms of our motion controllers. First, get the right motion controller. Then, get its world transform and the forward and up vector. Split the world transform pin and multiply the forward vector by a float of -2 and the up vector by a float of 9. These are values that you can play around with to adjust the hand position of the mesh. Then add the scale, forward and up vector to the motion controller's location and set it as the RMC transform location. The rotation and scale can be input directly from the world transform. Then simply copy the logic to do the same for the left motion controller. At last, create a new variable of type float and call it height ratio. Get the height ratio from your character and set the value to that variable. Next, we want to create a control rig for moving the elbows based on our hand rotation. In the animation blueprint folder, right-click, navigate to animation and then control rig and select the control rig. Let's call it CR_elbows. Inside the control rig, select the tab Rig Hierarchy and select Import Hierarchy. Then select the SKM Mani skeletal mesh. Add a new control for the following bones: lower arm L, lower arm R, hand L and hand R. Move the lower arm controls to the matching bone. Hey, it's the editing me here. I noticed a little mistake I made. Here in the control rig, we attached the lower arm R control to the lower arm. However, we want to attach it to the hand. So do this for the right and left lower arm control. We will use these controls to move the elbows based on the hand rotation. Set the offset of the hand controls to 0. If you find the elbows are too close to the body, you can also adjust the lower arm controls and add an offset with that. In the graph, get a basic IK and select the bones as follows. First the upper arm L, then the lower arm L, and the effector item is the hand L. Expand the effector transform. Get the hand control, call the from world node, and connect its translation to the effective translation. Get the hand L bone transform and connect its rotation to the effector rotation. For the pole vector, we get the lower arm L control and input its translation into the pole vector. The pole vector kind should be set to location. The primary axis should be 1.0 for the x value and 0.0 for y and z. The secondary axis should be -1 for the y value and 0.0 for the x and z value. Now simply duplicate the nodes and change every bone and control to the right variant. Also make sure to change the x value of the primary axis to -1 and the y value of the secondary axis to 1.0. Before we can continue, we need some animations. For this tutorial, I will use the animation starter pack from Unreal. In the future, I will use animations from Mixamo. However, I will first create another tutorial that will show you how you can retarget those animations. So let's go to the animation starter pack folder. Right-click any animation and select Retarget Animations. Make sure the option Auto Generate Retargeter is ticked and select the SKM Mani Skeletal Mesh for the target mesh. Then click on the Export Retarget Assets button and store the asset in a newly created folder called Animations. Then go back to the Animation Retargeting menu, untick Auto Generate Retargeter and select the created RTG Auto Generated Retarget asset. Then search Idle in the search box. Select the Crouch Idle Rifle Iron Sights and the Prone Idle animations and click on Export Animations. Now that we have our animations, let's create a new blend space. To do that, right-click in the Animation Blueprint folder, go to Animation and then Legacy and select the blend space 1D. Create the blend space for the SK Mannequin Skeleton and call it BS_height. Open the blend space and expand the horizontal axis section and rename it to height ratio. Set the minimum axis to 0.0 and the maximum to 1.0. Set the grid divisions to 10 and tick the Snap to Grid option. Then go to the bottom right and search for idle. Drag out the mm_idle animation to the value 1.0, the Crouch Idle Rifle Iron Sights to the value 0.6 and the Prone Idle to 0.3. These are values that I got through experimentation, so feel free to change them and find what works better for you. Now we can go back into the animation blueprint. In the AnimGraph, get the camera rotation variable and a transform bone node. Connect the camera rotation to the transform rotation. In the transform node, go to the rotation section and select Replace Existing from the drop-down menu. The rotation space should be world space. The bone to modify is the head bone. Next, we will set up the IK for the arms. Get a fabric node and input the RMC transform into its transform. Set the effective target to the hand R bone and the space to world space. We also want to copy the target rotation. The tip bone is the hand R bone and the root bone is the clavicle R bone. You can also use the upper arm bone as the root bone. However, I found the movement to be a bit too restricted when stretching my real arm. Then do the same for the left arm. Next, get another transform bone node. The bone to modify is the head bone. In the rotation section, we want to add to existing and set the space to bone space. Set the y-axis value to 90 and the z value to -90 degrees. Next, we need to add a rotation offset to the hands. So again, get a transform node and set the bone to modify to the hand R bone. The rotation mode and space is the same as for the head. The y value should be 70 and the z value 180 degrees. For the left hand bone, set the x value to 180 and the y value to -70 degrees. Next, get a layered blend per bone node and connect the transforms to the second input. Select the node and under Layer Setup, add a branch filter. Set the bone name to Spine 02 and the blend depth to 0. Get the previously created blend space BS_height and connect it to the first input of the layered blend per bone node. Get the height ratio variable and input it into the blend space. Now we are almost done. All we need to do is to add a control rig. Select the created CR_elbows control rig class and tick the Use Pin option for the right and left hand control. Then input the right and left motion controller transforms. Before we can test our character, go back to the character blueprint, select the mesh, and set the anim class to our created animation blueprint. Now let's test our character. As you can see, the head mesh does not interfere with our view, while it follows the camera when going from a standing position to proning. If you want your head to collide with the mesh, go to the mesh physics asset and select the hand collision boxes and the other collision boxes you want them to collide with. However, make sure to disable collisions between neighboring bodies, since this will cause instabilities or significantly restrict movement. In the end, make sure to select every collision box you don't want to collide with each other and to disable their collisions. When selecting a collision box, it will collide with everything purple and will ignore everything gray. In the next part of the series, we will be expanding on the movement system together with movement animations. Let me know in the comments if there is a tutorial you would like me to create, or if you need any help with this one. I hope you found this tutorial helpful. If you did, leave a like and subscribe, and I will see you next time. Bye!